One common construction we see in geometry is a pair of parallel lines being cut by a transversal. Now, I personally like to label these angles just so I can keep them straight in my mind and on the paper. So we see we have 1, 2, 3, and 4 on the top, 5, 6, 7, 8 on the bottom. Now, this is a common construction you might see. For example, we might see it in a square or a rectangle. Here we see our common quadrilaterals, the rectangle and the parallelogram. Let's extend these lines a little bit. Any quadrilateral we see, if we have parallel lines, we can just extend those, extend one of the sides, and now we have our parallel lines with our transversal. So if we know the properties of the parallel lines with the transversal cutting it, it'll also inform us some of the properties of various quadrilaterals. Let's take a look at this construction again. We see 8 angles. How many possible unique measures are there? Take a guess now. By the end of the video, you should be able to tell. I'll put an upper bound on it. There's 8 angles, so that's the max. But how many maximum unique ones do you think there are? Well, let's go through some properties so we can actually learn about this. So the first property, one you may already know, is vertical angles. As you could see in our construction, we have plenty of pairs of vertical angles. And as we know about our vertical angles, if you have two lines intersecting each other, the opposite angles will be equal. So no matter where we turn this, 42 here matches the 42 here, 138 matches the 138. So let's take another look at these angles. This time I have it in paint so we can easily edit it. Where do we see vertical angles here? Well, we see 1 and 4, 3 and 2. We have plenty of different pairs here. So why don't we start circling some? And I'll try and color code as well. We'll very quickly color these. 1 and 4 matching, 3 and 2 matching, 5 and 8 matching, 6 and 7 matching. These are all of our pairs of vertical angles. So now we'll move on to a new property, corresponding angle. So we first see one angle here. It's about equal to angle 6 on our drawing. Why don't we try and measure the angle? 68 degrees, okay. Well, what else can we do? Let's switch back to the move tool. And we can actually move this whole angle, or a representation of the angle, up. And we see, hey, it's pretty much equal to what it was down here, and it fits in very nice. What do you think? Are these angles equal as well? Let's take a measure. Also 68. Okay, so we had an angle, and we measured it, and then we moved it back down, and we found that the two angles are equal. And look, we have them both labeled conveniently for us. So what does that tell us? Well, if we have an angle on the bottom section, if we move up to the equivalent one on the top, they're also equal. So what angles correspond here? Why don't we first write down all of our vertical angles before we write down the corresponding angles? Vertical angles. These vertical angle pairs are equal to each other. So angle 1 equals angle 4. Angle 2 equals angle 3. Angle 5 equals angle 8. And angle 6 equals angle 7. Okay. How about our corresponding angles? Let's write those down too. Six equals 2. 8 equals 4. 7 equals 3. And 5 equals 1. Okay, so we can see a few relationships between the different angles here. With all these relationships between these different angles, what do we know? I'll give you a hint in a second to think about it. Okay, I think that hint was pretty obvious, but we can use the transitive property to find a few more relationships, can't we? The transitive property states that, let's say, if A equals B and B equals C, well then A equals C. So why don't we start with angle 1? Well, angle 1 equals angle 4. What else does angle 4 equal? Angle 4 equals angle 8. So angle 1 equals 4 equals 8. A equal anything else? Yes, it's another vertical pair with 5. Okay, how about something else? Well, we don't have 2 in there, so why don't we look at 2? 2 is a vertical angle with 3. 3 corresponds with angle 7. And angle 7 is a vertical angle with 6. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8. That covers all 8 of our angles. And we see that there's only really 2 pairs, 2 different unique measures. Oh, very interesting. There's one final property I'd like to cover, and that's alternate interior angles. Now, I think you guys have probably intuited this property based on our last examination with the transitive property. But, so we see we have this one angle here. Well, we slide it up. Okay, it's equal to this one up here. Now it asks us to spin it. Okay, I'm spinning it around. And now we've spun it to the vertical angle of that one we slid it to. And we see it fits again. This property here is known as the alternate interior angle theorem. Now, this is, of course, something we just intuited by first finding vertical angles and then using corresponding angles and the transitive property to show that the two are equal. But now we can say by using by using the alternate interior angle theorem, angle 6 and angle 3 are equal, as opposed to saying angle 6 corresponds with angle 2, angle 2 is the vertical angle with angle 3, thus angle 6 equals angle 3. So now at this point, we should be able to answer the question from the start of the video, where I asked, how many unique angles are there in this construction here? Well, as we saw, after using the transitive property and grouping the angles, we have 2 equal measures. I've always felt it was kind of elegant to go from 8 different angles, and once we group and organize them together, we were left with only 2 different unique measures. There's only 2 different angle measures in here. 1 and 3 are 2 different angles that are, of course, supplementary, and all those 2 angles are found in the other 6 places on the construction. Finally, I do just want to return to our our rectangle and our parallelogram, specifically the rectangle. Now, if we see here, we do have right angles because it's a rectangle. We have 4 right angles. And why don't we look at the construction on the right here? If we go to the vertical angles of this right angle, that's equal. Corresponding angles, well, that would be equal down here. Vertical angles equals here. Vertical angles again. Now we have 8 different right angles in the construction where the transversal makes a right angle with the 2 parallel lines, just leaving us with just 1 measure. So that covers today's geometry lesson and one of my favorite constructions of all time, the parallel lines cut by a transversal.